Approximate with 4 subintervals the area under the integral from 0 to 4, 15 minus x squared over 2 d of x, using right hand, left hand sum, and midpoint and trapezoid sums.
We're going to start with right and left hand Riemann sums. To do this, you find the points, you break it up into 4 subintervals since we're using 4 subintervals, and you measure from, for right hand, you take the right upper side and go over, and you take the area of each of those rectangles to estimate the area under the curve. For left-hand sums, you take the point on the left side and use that rectangle to estimate the area under the curve. For this curve, the left-hand sum is an overestimation and the right-hand sum is an underestimation.
Alright, so this is the midpoint sum, and it's basically the same concept as left and right hand, using rectangles to find the area underneath the curve. But with this one, you take the point at 0.5 because it's in the middle of 0 and 1 to get the midway between, and this one is the most accurate representation of the actual area.
Alright, so next we have the trapezoid Riemann sums, which is just you take a trapezoid using the 4 subintervals and you add that together to get the area. And the purpose of the trapezoid is to get the average of both the right hand and the left hand Riemann sums. So to start, we need to find the area of this first trapezoid, which is, you'll do base 1 plus base 2, 15 plus 14.5, divided by 2, times the height of the trapezoid, which in this case is just 1. So you get 14.75. Now as you take the area of all the rest of these trapezoids, as demonstrated here, you can add them together to find the approximated Riemann sum of the trapezoid, which is also equal to the average of the right and the left hand Riemann sums of 49.
So for the midpoint, it's basically just taking the area of a rectangle, length times width, so 14.875 times 1 because the base is just 1. And the base is 1 for all of them, so you're just taking the height, 13.875, 11.875, and 8.875. You add it all up, and it becomes 49.5.
For right and left hand Riemann sums, you're just calculating the area of the equal rectangles since we're using equal subintervals. So you just take the height times the base, and the base for all of them will be 1, as you can see here. And the height for this one was, this is right hand, it's 14.5, 13, 10.5, and 7. And for left hand, it's the height of 15, 14.5, 13, and 10.5. And once you add them all up, you get 53 and 45. As you can see up here, we've shown all the different Riemann sums and their accuracy for this particular equation. Right and left are the farthest away, and it changes which one's closer. Trapezoid will always be the second closest, and midpoint will always be the closest. As you can see, it's only off by 0.16.